Hello and welcome to another ramble. We are rambling about IEB May 2025 paper 1, question 7b, I believe. Yes. Right. Consider k is equal to x over 2 times x minus 4 for k is an element of real numbers. For which values of k will x be real? Right, so we're looking at a nature of roots question, at least at the surface. That's immediately what stands out for me. And for nature of roots, we are necessarily then looking at a quadratic equation, right? And I can see that if I were to expand on this side, I would end up with a quadratic expression. So I need to look at this as a quadratic equation. So I'm going to start indeed by expanding the right hand side, so that will be x squared over 2 minus 4x over 2, so that's pretty much a half x squared minus 2x, right? And then we know that with quadratic equations everything has to be on one side. Well, one of the sides needs to be 0. So this is essentially then this same equation but rewritten in the quadratic form that we're used to. And we then know that what tells us whether the roots are real or not is the discriminant of the equation. So the discriminant of this equation, b squared minus 4ac, is going to be minus 2 squared minus 4 times a half minus k. So that will be 4 minus, so we've got minus and a minus, so that's going to be a plus, and then 4 times a half is 2 times k, so that will be 2k. So that's actually quite cute. So we know that our solutions are real when the discriminant is greater than or equal to 0, right? Because remember, the discriminant is that part of the quadratic formula that lives under the square root. So that's why it has such a big say in what kinds of solutions our quadratic equation has, because if this thing is a negative number, then this square root is going to give us a non-real number, which is going to make the full thing a non-real number. But if this thing is 0 or positive, then the square root will also be then 0 or positive, and then this whole thing will be a real number. Right, so we are pretty much trying to figure out for which values of k will this guy be 0 or more. So that will be 2k must be greater than or equal to negative 4, and so k must be greater than negative 4 over 2. K must be something greater than or equal to negative 2. I won't lie, when I first saw this question, I thought it was going to be a lot trickier than this, but I think that the important bit was to identify that this is a nature of roots question, that yes, this equation looks weird, but actually deep down at its core, inside its heart, it is a quadratic equation. And how do we figure out whether the roots of a quadratic equation are real or non-real or blah blah? We use the discriminant. So right,